Now, what is DNS and how DNS works? First, what is DNS? The domain name system is the phone book of the internet. Humans access information online through domain names like NewYorkTimes.com or Google.com or whatever.com, .net, etc. etc. So web browser interact through Internet Protocol IP addresses. DNS translate domain names to IP addresses so browsers can load internet resources. Each device connected to the internet has a unique IP address which other machines use to find the device. DNS servers eliminate the need for humans to memorize IP addresses such as 192.168.1.1 in IPv4 or more complex newer alphanumeric IP addresses such as the IPv4 2400 with colon CP00 etc etc. Okay, so DNS server will eliminate the need for the human to memorize it. Okay, now how does DNS work? So the process of DNS resolution involves converting a host name such as example.com into a computer-friendly IP address such as 192.168 etc etc. So an IP address is given to each device on the internet, and that address is necessary to find the appropriate internet device, like a street address is used to find a particular home. When a user wants to load a web page, a translation must occur between what the user types into their web browser, example.com, and the machine-friendly address necessary to locate the example.com web page. So in order to understand the process behind the DNS resolution, it is important to learn about the different hardware components a DNS query must pass between. For the web browser, the DNS lookup occurs behind the scenes and requires no interaction from the user's computer apart from the initial request. Now we have 4 DNS servers for loading a web page. Okay, so there are 4 DNS servers involved in loading a web page. 4 types, I mean. We have the DNS recursor, we have root name servers, we have TLD name servers, and we have the authoritative name server. Now let's start with the DNS recursor. The recursor can be thought of as a librarian who is asked to go find a particular book somewhere in the library. The DNS recursor is a server designed to receive queries from client machines through applications such as web browsers. Typically, the recursor is then responsible for making additional requests in order to satisfy the client's DNS query. Now we have the root name server. The root name server is the first step in translating or resolving human-readable host names into IP addresses. It can be thought of like an index in a library that points to different racks of books. Typically, it serves as a reference to other more specific locations. We have the TLD name server. This is the TLD or the top level domain server, can be thought of as a specific rack of books in a library. This name server is the next step in the search for specific IP address, and it hosts the last portion of a host name. In example.com, the TLD server here is com, .net, .org, etc, etc. Okay, this is the top level domain, okay, which is the part, the com here. Okay, we have the authoritative name server. This final name server can be thought of as a dictionary on a rack of books in which specific name can be translated into its definition. The authoritative name server is the last stop in the name server query, and if the authoritative name server has access to the requested record, it will return the IP addresses of the requested host name back to the DNS recursor, the librarian, and that made the initial request. Now, what are the steps in the DNS lookup? So for most situations, DNS is concerned with domain name being translated into the appropriate IP address. To learn how this process works, it helps to follow the path of DNS lookup as it travels from a web browser through the DNS lookup process and back again. So let's take a look at the steps. So often DNS lookup information will be cached either locally inside the querying computer or remotely in the DNS infrastructure, and there are typically 8 steps in the DNS lookup. When DNS information is cached, steps are skipped from DNS lookup process, which makes it quicker. So let's start with the 8 steps in the DNS lookup. First, the user types example.com into a web browser and the query travels into the internet and it's received by a DNS recursive resolver. The resolver then queries a DNS root namespace dot And the root server then responds to the resolver with the address of the top level domain TLD DNS server such as .com, .net, .org, etc., etc., which stores the information for its domains. When searching for example .com, our request is pointed toward the .com TLD. Then the resolver then makes the request to the .com TLD. The TLD server then responds with the IP address of the domain's name server.com. And lastly, the recursive resolver sends the query to the domain name server. And then the IP address for example.com is returned to the resolver from the name server. And the DNS resolver then responds to the web browser with the IP address of the domain requested initially. So once the 8th step of the DNS lookup have returned the IP address for the example.com, the browser is able to make the request for the web page. The browser makes HTTP request to the IP address. The server at that IP returns the web page to be rendered in a browser. Now, it was 8 step because until we get the IP address, this is the 8th step in the DNS. Now, these 2 steps, the 9th and 10th, this is on the browser level, okay? Now here is an example, okay, about a complete DNS lookup and web page query. So here you can see that this is the one with blue, this is to recursive query, and this one with black, this is iterative query. So we start from here. So the example.com, as you can see, we get from the DNS resolver, and it will go to the root server, and it will get it back to the DNS resolver. Then it will go to the TLD server, specific TLD server, as we mentioned, .com, and it will return back the IP. Then it will go to the example.com, which is here you can see that this is the client this is our laptop or computer we are requesting. The example.com, it will return to the DNS resolver, and it will go back to the laptop or the computer. Okay, now the computer here, or our laptop or computer, it will request to the server of the example.com with the specific IP, and it will return back the result. Okay, now what is DNS caching and where does DNS caching occur? So the purpose of caching is to temporarily store data in location that results in improvement in performance and reliability for data requests. So DNS caching involves storing data closer to the requesting client so that the DNS query can be resolved earlier, and additional queries further down the DNS lookup chain can be avoided, thereby improving load times and reducing bandwidth CPU consumption. DNS data can be cached in a variety of locations, each of which will store DNS records for a set amount of time determined by time to live the TTL. And we have the browser DNS caching. So modern web browsers are designed by default to cache DNS records for a set amount of time. The purpose here is obvious. The closer the DNS caching occurs to the web browser, the fewer processing steps must be taken in order to check the cache and make the correct request to an IP address. When a request is made for DNS record, the browser cache is the first location cached for the requested record. And in Chrome, you can see the status of your DNS cache by going to Chrome net internals / with hashtag and DNS. Okay. Now we have on the operating system level, we have a DNS caching, OS. So the OS level DNS resolver is the second and the last local stop before DNS query leaves your machine. So the process inside your operating system that is designed to handle this query, commonly called a stub resolver or DNS client. When a stub resolver gets a request from application, it first checks its own cache to see if it has the record, and if it doesn't, then send DNS query with recursive flag set outside the local network to a DNS recursive resolver inside the internet service provider, the ISP, which is the internet. And when the recursive resolver inside the ISP receives the DNS query, like all the previous steps, it will also check to see if the requested host to IP address translation is already stored inside its local persistence layer. Alright? Now this was, as we mentioned, this was like the general idea how DNS works. Alright, thanks for watching.